Okay, here's an example from homework 9.1 about two proportion confidence interval and tests for two population proportions. This is similar to an example we did in class. It says test the given claim, identify the null hypothesis, the alternative hypothesis, test statistic, p-value, and state a conclusion, as well as the final conclusion that addresses the original claim. Now, the situation here is that among 2,179 passenger cars in a particular region, 253 had only rear license plates. And among 324 commercial trucks in the region, 48 had only rear license plates. A reasonable hypothesis is that the commercial truck owners violate the law requiring front license plates at a higher rate than owners of passenger cars. It says to use a 0.1 significance level to test that hypothesis. And it's important to note up here that it says let population 1 correspond to passenger cars and population 2 correspond to commercial trucks. So if that is the case, and the hypothesis is that truck owners violate the law at a higher rate than passenger car owners, then our alternative hypothesis will be that P1, the car owners, have a lower rate, so P1 is less than P2. Cars violate less often than the trucks do. So we're going to compare the two sample proportions of cars and trucks. So I went ahead and created a little table over here. Cars is P1, and cars with rear license plates only, total number of cars, and then the sample proportion of cars with rear license plates only. And the same for trucks, population 2. So we're going to go ahead and put these into our calculator to see how we arrive at our test statistic. Okay, so P1 is the cars, so that's going to be 253 over 2,179, and our N1 is the total number of cars, 2,179. Our sample proportion for trucks is 48 over 324. And the total number of trucks, 324. Now, they say they want a 0.1 significance level. That is a 0.9, I'm sorry, yeah, 0.9 confidence level. Okay, 90% confident. Okay, so you can see our test statistic here, right there, is negative 1.65. So that's where we got that from. The next thing they ask us for is our p-value. This is a left tail test. And so right here, our p-value is going to be 0.049. And we're going to compare that to our alpha level of 0.1. And p here is actually lower than our significance level. Therefore, since our p-value is lower than our significance level, we're going to reject the null hypothesis. There is sufficient evidence to support the claim that commercial truck owners violate the laws requiring front license plates at a higher rate than owners of passenger cars. All right. Now it's going to ask us for a confidence interval. And since this is a left-tailed test, in order to arrive at this confidence interval, we're going to have to double our significance level from 0.1 to 0.2. And so our confidence level is going to become 1 minus 2 times 0.1 or 0.8. So for our confidence interval, our confidence level is 0.8. And then you can see right here, lower confidence is negative 0.0588. Upper confidence is negative 0.0 negative 0.0053, and so we can interpret our confidence interval. So we can see here that the confidence interval does not include 0, does not contain 0, so there is a significant difference between the two population proportions, or there's evidence for a significant difference. And so there is sufficient evidence to support the claim that the truck owners violate the law requiring front license plates at a higher rate than passenger car owners. Again, we used the confidence interval and statistical test calculator for comparing two proportions to solve this problem.